We're going to try and do something special today. On the left here, I have my crystal radio set. This is one that I picked up in Switzerland at the ham radio convention about 10 or 15 years ago. And this set uses an actual crystal diode detector, as well as a removable coils. And what I'm going to do is I'm going to use my Heathkit signal tracer in lieu of a pair of these headphones. This is some high impedance headphones, so that we'll be able to actually hear what's coming out of this radio during the video. And what I would like to do is use my oscilloscope in the background, the Tektronix 2235, to actually view the output of this crystal radio throughout the different stages. What I'd like to do is just show right now that the crystal has been set up and we are on station right now.
Hi, this is Orlando Magic CEO Alex Martins. Since day one, the Orlando Magic have trusted the professionals at Jewett Orthopedic Clinic.
But first, what I'd like to do is take a closer look at the radio itself. This is where we would have our headphone connection. I have the signal tracer in lieu of that headphone connection. This is the ground connection. This is one of the reasons why I'm doing this in the ham radio room and not the electronics room, because this is the only room that has a really good ground, which is what I need for a crystal radio set. This is the coil. These are actually detachable, and they are strung for different frequencies. This one is 510 kilohertz, and the coils just lock into there. The coil is tuned in conjunction with this capacitor to get you at the exact frequency that you need. And finally, we have the crystal detector. This one is an actual cat whisker crystal detector. I do have a diode if I want to cheat, but I don't need to use it because you can see the detector actually works just fine. Here's a close-up of the actual crystal. We can see the cat whisker and the adjustable arm, and it's making its way down. See if I can focus in on that, to the actual piece of crystal. About as close as I could get. A quick look inside will reveal how surprisingly simple it is. We can see a capacitor right here, as well as a capacitor right here. And this is the open air capacitor. This one says 550 28 picofarad. I also see that this one is 550. Looking over here, we see that this one is says 75. So I don't know exactly how this was labeled up in here. This one right here serves to take the RF after it goes through the detector and have that RF channel to ground over here. This one is tied across the antenna, and this one is obviously for the tuner. You'll also notice that everything uses direct connection, very neat, very thick, low resistance. The way that it's done purposely like this to maximize efficiency. Another note to further maximize efficiency, everything is bent on a 90-degree angle. You can see that right here. All bends 90 degrees. I don't listen to shortwave radio, so I don't have a long antenna outside the house. What I did was, and another reason why I'm in the ham radio room, is I have connected to the tip or the center of the buddy pole antenna, my HF antenna going out back. So at least this is connected to the 20-meter antenna for the ham radio, which is not ideal for a crystal radio set. Such a radio would require an extremely long wire, but this is what I had, so it obviously it's working enough to use on the signal tracer to be able to capture a signal, and obviously it should not be a problem for the Tektronix to capture a signal as well, so we will call this sufficient for our needs right now. I'll also demonstrate that a degree of tuning is possible if two stations are close together.
That's 1-800-500-7544.
I'm tuning off frequency. There's one station. And you could just hear another station right at the end, but it's just off. The limitations of this are such that, you know, if they're not close together, I can't do it.
We see beyond minor cosmetic defects and will offer you top dollar for your trade.
And there we are, right on frequency. So I decided to put the oscilloscope on this first connection here by the detector, and this is essentially a connection here to this coil. And what this does is this allows us to see the radio frequency off of the tune circuit here between this coil and the capacitor to give us this exact frequency. And it is the modulated AM signal. So I'm going to move the camera over so we could get a good look at it on the oscilloscope, perhaps even dim the lights. This particular signal is very hard to see with the light on, so I'm going to shut the light off for a second so we can take a look at it. Here it's a lot easier to see. I'll make some adjustments. We can see this is before the diode. I'm going to adjust the time domain here so we can look at it from a couple of different ways.
See, Jordan, I like line of thinking. I think that the four best means the four best, and I don't care if all four of them are in the SEC. I don't care if all four of them are in the ACC. I don't care where teams come from. I want the four best teams in the college football playoff, no matter who they are. They're going to try to piece together.
Again, this still has to go through the diode. It needs to be rectified, and then it would have to go through a capacitor that strip out the actual RF to leave the audio frequency. It's easy to associate the output of the oscilloscope with the signal tracer because, you know, they're running in tandem. But the signals that we see here are coming entirely from the air and are not amplified in any way, except obviously for the display. So I could go and just shut this off. And the signal is still being pumped through because, like I said, this is just a crystal radio set and doesn't require any electricity. Turn it back on.
I mean, that's going to be an interesting situation to be in when you start to scenario. Let's take the big
so on the other side of this diode, like I had mentioned earlier, is also a capacitor to ground. So it's going to pull that residual RF to ground as well. So whatever DC comes through the diode to become audio, but the RF is going to go away. So I'm going to move this over. It's also going to detune the radio, so I'm going to have to retune it. But you can hear it detuned right there. So now I have to adjust it.
Everybody's kind of beating each other. That makes all those wins within that conference carry a little less weight, and that's why I think there is a good chance the Big Ten ends up getting left out. Well, and I'll sort of harken back to earlier. I was trashing the SEC, but right now, Big Ten fans, when you complain about this at the end of the year, you got to remember there was a whole period in the SEC
right there.
That's exactly what was happening. You had all of these really good SEC teams, but because they were taking a couple of losses throughout the process, and they were devaluing each other, that's exactly what the Big Ten East especially is going through right now. You know what, I think...
And this is the audio that would be hooked to the headphones that you would be able to hear. Right now, this audio is being outputted to the signal tracer, and we're listening to that here. We could, however, move the oscilloscope probe to the same point that the signal tracer is using as an input.
It's fair throughout the rest of the season.
So now we're effectively coupled to the same input.
I hope eventually those next four teams, and I think you would end up.
We could see an average power of just over 3 gradicules looking at the station we have tuned in. At 20 millivolts, we're looking at 60 millivolts of output voltage, giving us an idea of what kind of voltage is going into these headphones. It's important to note that these voltage values are done pretty much with no load conditions. The oscilloscope and the signal tracer are extremely high impedance inputs, so there's not really any voltage drop. If I were to use something like the headphones, which I have plugged in but in an open condition right now, and short them, we'll see that there will be in fact a voltage drop. And now the headphones are connected, and we can see that the signal has dropped substantially with the headphones now connected to this unit. These are very high impedance headphones, like 3,000 ohm headphones, but obviously significantly lower impedance than the signal tracer or the oscilloscope. Now I've disconnected it. We can see the voltages back up again.
Thank you for watching this quick demonstration of my crystal radio set. I hope you enjoyed it.